Three, two, one. Hi, my name is Noah Gift, and I'm going to talk to Piero Molino about Ludwig and Predibase today. It's going to be a very interesting conversation on declarative ML. Okay, go ahead and enjoy. And maybe before you begin, I could just ask a couple questions,
Sounds
if
good.
it's okay. So one of the questions, if I'm just remembering our initial conversation that you had, if and correct me if it's incorrect, but I remember you had just left potentially Uber, and you had been working on a tool to do declarative AutoML. And I think I remember you saying that one of the things that you're very interested in is this idea of democratizing the AutoML process so that it doesn't necessarily belong to some huge entity, right? Which I think, if I remember correctly, I think is a very interesting goal. Is that still something you're interested in for Ludwig?
Yeah, absolutely. I would say between Ludwig and Predibase, which is the company that recently started, I would say the goal is still the same. To try to. So I think the word democratize is a little bit overused to a certain extent. So I would say my goal is to make it possible for more people to be able to do machine learning, either from the perspective of training models, but also from the perspective of consuming models and using models in a form and place that makes sense for a bigger audience of potential users. And so you can imagine that even just querying an API still requires some amount of technical knowledge, and knowing and understanding the formats of the inputs and the outputs and all of those things is still like a barrier of entry for people that maybe, I don't know, maybe they're using a BI tool or something like that. So even just the little connection is still pretty difficult. And I don't claim that, we are all the way there, but that's the, let's say, end goal and the North Star that we're trying to aim towards, right?
And with Ludwig, would you say that you're, in a sense, adding an alternative for someone who, let's say, doesn't want to use uh, like a kind of a big tech company like Google, Facebook, Microsoft, like maybe they, for whatever reason, they want to keep things. Let's actually take Duke for a good example. So let's just do hypothetical and say that Duke Health, which is worldwide one of the better hospitals, and has very interesting research and very well renowned hospital. They have proprietary data sets. They have maybe customer agreements and all kinds of really tricky things to deal with. And let's say that they just, for whatever reason, they can't get to the cloud,
Mhm.
but they wanted to do AutoML, and maybe an anesthesiologist or a cancer researcher, they have like incredible data that maybe no one else in the world has. Would that be, a scenario where Ludwig could play a role?
I would say definitely for Ludwig in particular, um, you know, um, um, definitely could be helpful for those people that have their own data and they cannot like share it or put it somewhere, and they can definitely run their own AutoML capabilities with Ludwig on their data, on their machines you know, without blockers, really, right? So that's definitely something that could help. And in particular, the kind of persona, if you want, that I imagine for Ludwig specifically could be a good user is like someone who maybe someone who may not want or have the deep knowledge for being able to write their own deep learning model, but may want to do something valuable with images, text, and combination of multimodal data, which is something that usually, AutoML solutions do not support. Most AutoML solutions usually support just tabular data. And so if you want to use, these kind of additional modalities, definitely Ludwig can help and do AutoML to do AutoML on these modalities without leaving the infrastructure that you are in, right? So that's definitely a really good example what you mentioned of a potential use case.
Yeah, that's interesting, and maybe I'll spread the word to some of the people in the Duke Health industry, because it's staggering actually how much stuff is happening, and from what I gather, it's just even if they wanted to, it's extremely complicated for logistical and legal reasons to even move forward. But if they are able to use a tool like this, and it seems like that those kind of it's hard to sometimes find the right persona for some open source solutions, but this seems like the one. And it seems like there's other organizations that could have the same one.
Yeah, definitely. We have been interacting with several organizations, and we are seeing that it seems like it's a common problem, right? So something that is beyond the single organization, and potentially there's a market for it, and that's the reason why we actually ended up starting the company around it, right?
And then I'm assuming, let's say that let's say that some cancer researchers that again have proprietary data, they start to use Ludwig, and then they get really good results with it, and then for whatever reason they start to get some of the tangled legal things solved, and then they also are making so much progress with it, then they want some support and they want to use a commercial tool. Is that then the pathway that you would suggest they would then use your company?
Yeah, so what we're doing at Predibase is certainly that. So adding, additional support and mostly enterprise style features to on top of Ludwig that makes it possible for, on one hand, make it very easy to manage it, to connect with data, to productionize it and use it for deployment and using it in real world use cases. So all of those things are taken care of. At the same time, there's also some additional functionalities that we believe are particularly potentially useful, that are kind of unique to the what we're building in Predibase as a platform, as opposed to Ludwig. So it's not one-on-one like managed Ludwig, but it's like managed Ludwig plus additional things. And maybe later I can show you some little examples of what I mean by that. But that's probably the best way to think about it.
Great. Yeah. So that to me was those are two of the, or I don't know how many questions I asked, but those were some of the big ones that I was interested in, and hopefully I can evangelize this and get some people at Duke to engage.
That sounds amazing, and again, super happy to have this connection, right? Great. So, Noam, how do you think what do you think is the best way for moving forward? I have a presentation if that's useful, and
yeah, we could. Yeah, I can make it so that you can do anything you want. Go ahead and share anything you'd like.
And I'm happy to make it as interactive as you want, right? So feel free to stop me at any moment in time. And also, there could be some slides that I have a lot of slides, a lot of content. Usually don't use all of it. I skip on some of them, but because I usually want to try to get like to the gist of it, I would say, sure, to the highest value pieces. But if at any moment in time there's things that you want to double click on, I'm super happy to dive deeper into them, right?
Yeah. So maybe I'll just, if something I feel like there'll be a point where it could add some value to dig into it a little bit, I'll interrupt you.
Perfect. Sounds great then. So let me start sharing my screen. All right. I think you should be able to see it.
Yes.
Cool. So let's talk about Ludwig, and for context, again, you have already looked at it in detail, so it maybe the beginning of this presentation is a little bit redundant, but just for setting the context, it is a declarative deep learning framework, and I'm going to talk in a second what I mean by that. and it's backed by the Linux Foundation, in particular the AI and data sub-organization of the Linux Foundation, which we're really grateful for. And it's like open source, an open source project under Apache license too, so people can use it without any issue for all their use cases. And the idea of declarative deep learning system, machine learning systems in general, is that we believe that there's kind of a false dichotomy between two kind of approaches to dealing with machine learning in many organizations. On one hand, you have people building like machine learning infrastructure on your own, like a do-it-yourself approach that usually uses low-level APIs. And on the other hand, you have the other extreme, which is the AutoML solution that kind of does everything for you to a certain extent, right? We believe that declarative machine learning systems could be a good intersection, could be at the intersection of these two approaches, and basically bring the best of both worlds. Because on one hand, you can have the flexibility of a do-it-yourself approach with the simplicity of an AutoML solution. And so without actually the downsides of both, because on one hand, you have the downside of having to build bespoke solution for all your machine learning problems, and that is costly and inefficient as an approach, as a process. And on the other hand, on AutoML solution, you have like the black box results of like, once you get the model out of it, it's either good or bad, but you cannot do much more with it after that, right? And so we want to, avoid these both kind of bad scenarios and bring the best of both approaches. And the goal is to eventually get to the point where non-experts, or at least less experts users, can do machine learning.
So quick question on this. So the low-level API, would you describe that as, let's say, someone automating SageMaker?
I would say even lower than that, like someone building their own TensorFlow or PyTorch code for each new problem that comes to them.
I see.
That would be, and then, having potentially to stitch with many different tools, and stitching it with a model monitoring tool, and then stitching it with a model deployment tool, and then stitching it with explanation tool, and all of that, right?
So basically they import TensorFlow as TF and just start building.
Right. So I would say in this case, you import Ludwig as something, and you don't have to write all that low-level code, and you don't have to do model monitoring by hand, and you don't have to do all these things, because they're already there, available for you and connected. Not all the pieces are there, but many of those pieces are there, and I actually can go into the details of which pieces are there, which ones are not. But it simplifies. It's a higher level abstraction, if you want, right?
Got it.
And when I developed this originally, when I was at Uber, it showed like that internal teams, even teams of engineers, for instance, were able to create models and get them into production very fast, even without having to go to like data science experts. Also there was this system called Overton that was created by Chris Ray, one of our co-founders, professor at Stanford, and he was at Apple when he created it. And it was really, really useful within Apple to decrease the time to value of most machine learning projects.
And so is Overton then included in CreateML?
In CreateML, you mean the Apple? So I honestly don't know. Okay. I don't think so. I believe that Overton is like an internal system at Apple. That is exposed to the users of machine learning through the Apple APIs, but I wasn't directly involved with it, so my information may not be like super correct, really. So
it's more of a systems, like the Overton is like a systems level tool that is, like it's embedded inside of Apple's data center or something,
I believe so. I believe.
Okay.
And I believe that it can output models in a format that then is digestible and usable by the Apple APIs, also on the phone or whatever.
Like the core ML model.
Exactly. I believe that it outputs models also in a compatible format with that. But again, the ideas between Ludwig and Overton were really, really similar, and so that's why we created that paper that was kind of showcasing both of them, I would say, at the same time. And so just to give an idea of what does it mean to actually talk about a declarative machine learning system, Ludwig specifically has this declarative interface that allows to train deep learning models now on PyTorch. We did this, we changed the backend from TensorFlow to PyTorch with the most recent release. And so you can declare a configuration that allows you to train and deploy model pipeline without actually to write the low-level machine learning code for that. And this is like a kind of analogous, if you want, to what you could do with like, I don't know, like what Kubernetes does for infrastructure, if you want, to a certain extent, well, with Helm charts and things like that, more than anything else, to like do that for machine learning. And so for starting, you have like a configuration where you just have to specify the inputs and the outputs. So the inputs and the targets, if you want, of your machine learning pipeline and their data type. And Ludwig, depending on the data type, will assemble a model and train a model and also make it possible to deploy a model for that task. And so, you know, this is an example of how to train, for instance, an intent classification model where you have some text as input and a category as output. And so this reduces, in some cases, the time of development from potentially months to days. You don't have to write the level of machine learning code, and it's readable and reproducible. At the same time, it retains the level of control that an expert may need, because this configuration system is very, very rich. And you can go there and change the models, the upper parameter of the architecture of the models, the preprocessing parameters, the training parameters. And so it's kind of complexity that is hidden from you, but is available on demand. And because each single of these parameters is basically a string in a configuration file instead of having to be implemented, really, it's really easy to iterate and improve. So you can write a model and then change it. You see that it overfits. And so you can say, well, increase like the value of the dropout to a higher level and then train again. It's just one line of configuration difference. And it's also extensible. Don't know if we want to get into those details. I have a slide about it later, but you can add your own components to it, like, for instance, a Python class with a specific interface that you have to respect, give it a name, and then you can use it in the configuration. So, for instance, you want to have another encoder which is not BERT, and you can, you know, write your own encoder, call it with a specific name, and then it becomes available in the configuration for everybody else. So you don't have to reinvent the wheel every single time. And finally, there's like advanced functionalities like upper parameter search, state-of-the-art models already baked in, distributed training. All those things are configured in the configuration. We don't have to do anything really other than specifying that you want those things to happen. Cool. All right. So moving forward, these are some statistics not super updated. Actually, the numbers have increased recently. So every single time that I show this slide is like at least a month old. So the numbers change every single time. But you know, it's a well adopted and starred project on GitHub with several downloads and many contributors. So it's a pretty active project, and it's been, you know, used in production by many companies. These are a subset of them, people contributing to it from many universities, and also integrations with a few, you know, MLOps projects. And okay, let's actually get down to it. I want to show you like a quick example to make clear what it looks like to develop a simple model with Ludwig. And let's assume that our example is we want to do text classification of news. And so we have two columns in a data set. One is news, and the other one is a class. And if you want to train a model using Ludwig for that, what you actually end up doing is you can run this command, Ludwig experiment, specify the data set, and specify the configuration. And here the configuration, we will get in much more detail on the configuration, but you can see that it's provided as a string, but also be provided as a YAML file. And the content here is a dictionary with a couple keys. One is input features, one is output features, and both are lists, and each entries of those lists are specification of those features. In this case, name news, which is the name of the column in the data set that contains the data, and then type text. Type is super important because depending on the type, different things happen behind the scenes, and I will show you in a second. So what this command does basically splits the data, but you can also provide the splits already if you want, trains on the training set, validating the validation set, and predicts on the test set. And the way it looks like after an epoch, you get like this nice table with some metrics and results. Then after a few epochs, this gets better. After a few epochs, it doesn't improve anymore. And so there's early stopping that happens. And so you can see then at the end evaluation on the evaluation metrics on the target, and both at the global level and the specific level for each class in this case, because of the multi-class classification problem. So this is just a quick example, but it gives you a general idea. And the powerful aspect of Ludwig is that you can specify different types of input data, different types of output data that define different tasks. And we will get into it in a second. And so if you want to do it programmatically, though, there's also a Python API. You just do install pip install Ludwig, and then you import Ludwig model from a Ludwig API. You provide the configuration. You call train, and then you can save it or then load it back if you want, and then call predict to obtain the prediction. It's as simple as that. You do basically deep learning in 3 lines of code. And if you want to serve the model, you can just call Ludwig serve and the path to the model that you have trained.
And are you behind the scenes? Is that using Fast API?
Yes, this one is using Fast API. Yes, spawns like a REST API with Fast API, and directs and does the slight data transformation from the JSON payload that you will send to the REST endpoint, and then provide the answers back.
And do you see that? Like I've been talking to a few people about this concept of model serving, and it does seem like there's a big opportunity for there to be a specialized web framework for model serving. Have you heard much about what's happening in that space?
So my take, at least for what is my experience directly with Ludwig, is that this Fast API thing is actually something that some people are using in production. Although I wouldn't advertise it as a production ideal case. Because basically every single time that you call Ludwig serve, it spawns like a Python interpreter that and some data preprocessing and some data transformation happens in Python, and it's not the most efficient way of using your resources, really. So we actually, Ludwig also allows you to export models to more compiled, formats, like for instance, I was mentioning Torch script. And so we see that as a more scalable way of deploying models. So you export to Torch script, and then you use like mechanisms specifically designed for serving those compiled models, and that reduces your costs dramatically. So if you're talking about like a specific open source project for serving generically any kind of model, I would take it with some skepticism, just because every library has its own slightly different way of packaging the models, and there would be a lot of work that will need to be done to make every single library output model format run efficiently. And also, I think in general, serving things in Python, it's not the best idea. And in most organizations that where they're serving like potentially hundreds or thousands of models, that's usually something that they try to avoid entirely, because again, they use too much resources. So that's the way I feel.
Yes. So it maybe is something too, where like way back in the day when I was in startups in San Francisco, we definitely experienced that with you don't want to build a server in Python. That's the worst possible thing you could build if you're making money off of a SaaS product. I mean, there's
exactly,
it's just bad, right? But what is interesting is containers and serverless have a little bit changed that, though. So it's not that can potentially be one solution for that, is if there's something that's containerized, then the inefficiency is kind of potentially diminished. But I guess to your other point, though, about the more of the generic model format, that also seems interesting. Just from, I guess, the reason I'm asking all this is that there's another company that I'm advising that does models. They do some things that are more like model serving. Like there's a framework called ML Run. I don't know if you've heard of it. And then they also have Nucleo, like this thing that can do Kubernetes based. And I was actually talking to them. I said, it seems like there's a very big opportunity for model serving. And so, I don't disagree with you that like the Python is maybe the worst solution for it, but from an open source perspective, it does seem like we're in a new era where I'm just guessing in like 2 years, there's got to be some tool that's like a fast API tool, but it's just for models.
Right. So if I look at the open source stuff, I think for me, the most promising in this space, again, I'm not super expert on the model serving, like I don't know all of them, honestly, but the one that seems promising for me is actually Triton from NVIDIA. It has some interesting features, in particular, automatic batching, and seems very, very efficient and does things mostly at the C level. So that is probably my favorite at the moment. I would say this is can be revised. Like my opinion here can be revised, but yeah. And by the way, just to replicate the example before, like if you wanted to create like that sentence, in this case, it's like a sentiment classification model, but again, it's the same concept of the intent classification or the news classification. You can see here, like this is like literally the end-to-end code that you have to write for training and predicting on a new data point, right?
Yeah,
so
this is nice. This is very nice.
It's very, very simple. Trying to make it as simple as possible, really. Cool. So this is like the general gist of it, but I wanted to go a little bit more into the details. And in particular, the details is basically how does the configuration system work? That's the core of it. And there are many functionalities, but I will probably fly over them and stop me if you think that there's something that's particularly valuable to double click on. So just in general, the training part works in a really simple way. You provide the data, there's some preprocessing, and the preprocessing creates some feature mappings, and also the preprocessed data itself that is provided to the model that then saves weights and hyperparameters. At prediction time, you take some new data, you use the same feature mappings for transforming data in the same preprocessed format that to make sure that training and test actually align, and then you load the weights and hyperparameters. The model with this preprocessed data produces some predictions and scores that are then mapped back into the data space with final predictions using, again, the mappings that you obtained before. So, for instance, one of those mappings could be, for instance, vocabulary for categorical features. The preprocessing transforms a string into an integer. The integer is used by the model to learn an embedding, for instance. And then when the model predicts a class and it's like, again, an integer, then it's mapped back into the string of that class. That is the actual value that was provided at the beginning as an input.
And when you're doing when you're building things from raw data, is there an assumed limit to the size of the data that you can use?
So this is actually something that I will touch upon later, but I would say the very first version of Ludwig relied on pandas for doing data transformation. And so the limit was basically the limit of the memory of the machine. Although right now we have two different backends. One is like we call local backend, the other one is called remote backend. And the remote backend uses Dask and Ray. So basically anything that you can process on a cluster of machines, that's the limit, which is, we have trained models on petabytes of data. So I would say we haven't encountered the limit yet. There is a limit for sure, like for everything, but...
So you could, with the current version of Ludwig, then you could basically just say, hey, I want to use Dask, and it's just like a one-line config or something like that.
Yeah, we'll show you. So basically, it's I want to use the remote backend. That's the way you specify it. And then, you have to pass the data as, like, for instance, S3 buckets or things like that, just because, all the machines on all the cluster need to have access to it, right? And so that's the caveat. But, obviously, if you are in a distributed system, you need to have or the data available somewhere, right?
Where do you think are like the limitations, or what would be one thing where, it's not a good use case where a company can use Ludwig?
Yeah, so we say, and I will get to it, but there's two aspects. One is that right now it's mostly useful for supervised training. So if you want to do other kinds of training right now, it's not particularly designed for those. Although we want to add, in particular, sub-supervision capabilities, probably just clustering and things like that. There's already other tools that do that. Again, we don't want to reinvent the wheel. We're really pragmatic in that sense. And the other aspect is the tasks that are supported depend on the types of the outputs. And so for some types, for some outputs, we have different types and we can perform some tasks. Others are missing. They could be added, but they're not there yet. Like for instance, we would want to have an output type which is bounding boxes for doing the detection in images, but right now it's not available. I think adding one will be relatively easy, but right now it's not supported. And so I will show you the ones that are supported right now. And so, yeah, actually, let's get under the hood. And so I think the magic of the value of it lies in the declarative configuration, the data type abstraction that I'm going to show you in a second, and a smart use of KV-args, which, if you're familiar with Python, is a mechanism for passing parameters as a dictionary and mapping it into the named parameters of a function within Python. And that makes it for a very flexible mapping from the configuration directly to the implementation functions. Objects and functions in the code. And so if you go back to the example, basically the configuration is this piece that I'm highlighting here. And what happens is that it actually overrides some defaults of the configuration. And it looks like this, which seems complicated, but it's actually divided in 5. It's actually not super complicated. It actually makes sense now that I'm going to cover it. It's divided in 5 different sections. And there's input features and output features, which we've already seen an example of. There's also a section called combiner, training, and preprocessing that I'm going to cover in a second. But why do you need this input, combiner, and output? It is because the underlying architecture is, we are calling it ECD, encoder, combiner, decoder, and basically allows you to do multimodal and multitask learning really easily on multiple data types. So we support many data types like text, category, number, binary, sequence, vector, set, bag, image, time series, audio and speech, H3, which is like a spatial indexing system, and date. And also on the output side, we support text generation, category, which means multi-class classification, number, which means regression, binary classification, sequence, which is like sequential decision making, vector, which means we predict an entire vector, and set, which allows to do multi-label classification. And the other ones, and we may want to add, are not there yet, but they will be there. So for instance, we don't support image segmentation at the moment, and we don't support object detection at the moment because they're not output data types to support it, but they will be added. And so in the end, by combining inputs and outputs, you can support many use cases. So text input, category output is text classification, and we've seen an example of that. But if you have images input and text as output, you can train an image captioning system. If you have category, number, and binary as input and number as output, then you can do like some classic regression tasks. Or you have audio and binary as output, you can do speaker verification. If you have text and image as input and binary as output, you can do visual question answering, where you have an image and some text asking a question about the image. And the answer is yes or no. Maybe it could be categorical to say, what is the answer among a set of answers? So, what I want to convey here is that depending on the combination of inputs and outputs, you can do many, many different machine learning tasks all at once without the need to implement anything specific for each of them. Moreover, for each input type and for each output type, you can have different encoders and different decoders. So just to make an example, for text, there is you can choose to use a stacked CNN, a parallel CNN, a stacked parallel CNN, an RNN, a CNN, or a transformer. And there's also, pre-trained models available for you. And basically, all you have to specify is the name, the type, and if you want to use a specific encoder, the name of that encoder. There's a bunch of parameters you can provide, and those all have defaults, and you can override them if you want. But you don't have to specify them if you don't want to. And so these maps, the KV-args things, 101 with the init function of the object implementing that encoder in the code base. And you can see that the parameters are exactly the same. So if you can add very easily a new encoder, give it a name and set some parameters, and those will be available from the configuration. And so if you want to use an RNN, you just have to change the encoder keyword from parallel CNN to RNN, and that's all you have to do. And the same is for a transformer. You specify I want to use a transformer, and that's it. And again, you can change the number of layers, the hidden sides, and all you want. And also you can use pre-trained models, like for instance, in this case, if you specify you want to have a text input and you can specify you want to use BERT, DistilBERT, T5, Roberta, we basically import the Hugging Face transformers. So whatever is available there is available also in Ludwig.
So do you need to have a Hugging Face account or no, just?
No, these are just the ones that are available in the open source. So.
Got it. And so that was actually your time going into a section I was actually very curious about, which is, could you see a scenario where something like Ludwig could be basically like a factory that would feed Hugging Face and receive from Hugging Face? So what I mean by that is that let's go back to an example where there are people that are maybe social scientists and they're just not strong at software engineering, but they have really incredible data and they want to, let's say, upload, I don't know, 100 models a week to TensorFlow, to Hugging Face. Could you see like Ludwig becoming like a tool where you could just start pumping models into a location like that, or is that a little outside of the scope of something someone would do?
I think you could. And I think there are something specific about the Ludwig models that would warrant potentially something specific for Ludwig, in particular, the fact that if I train a model with like 5 input features, some of text, some are images, and then there's 2 outputs or something like that, then I may want to import just, one component from that model, one sub-component from that model, instead of importing all of it entirely. And so if I uploaded it as a monolithic object into Hugging Face, then it becomes difficult to download just a piece of it, because Hugging Face has no notion of the internal structure of the Ludwig model. But other than this caveat, in general, definitely that's something that is feasible. And in general, I would say any model repository doesn't have to be Hugging Face; could be any other model repository.
Are there ones that you would recommend besides Hugging Face? It seems like we have a couple really cool things happening. Like one is, we just talked about it, the serving. We don't know yet what's going to happen. And then the other one is the model hosting. We don't know. Is there another one besides Hugging Face?
Honestly, I'm not super sure about the capabilities that are needed there. I think in most cases, you just need like a blob storage.
Yeah,
exactly. So like, for instance, if you have a local instance of MLflow, you may get almost the same kind of capabilities. So again, depends on also what they're going to add to their model repository kind of functionality. But depending on that, it could be more or less useful. I think right now in most cases it's just a place to upload them and a place to download them, with maybe some search functionalities. But again, depending on the use case and the needs, that could be true or false.
I mean, so I'll tell you the way I would, like, even though I like to get technical, there's a part of just the way I think about the world, which I could see myself spending 2-3 years never building a machine learning model myself, but only using pre-trained models.
Right.
Just tweaking, like pulling pieces out and just pulling the parts out that I care and just tuning it a little. Like, exactly. Do you see something like Ludwig could be potentially a tool for that, where the only thing someone does with it, they don't even use AutoML, they just disassemble huge GPT-3 models or whatever and just tweak it and then make it.
Yeah. Again, the example that I had here. Oh, sorry, this is taking too long. Sorry. Like the sample that I have here is actually a realistic example. Is a realistic example. So even if you remove the training part, this is all you have to do to basically train a BERT model, actually fine-tune a BERT model that is downloaded from model weights repository and fine-tuned it on your specific tasks. So those are literally those 7 lines of configuration. You need to do anything else, right? And so if you want to tweak it and let's say change a little bit the dropout or change a little bit, it's just 1 line additional. So I think that's a perfect use case. What you're mentioning is a perfect use case.
Good. I think there's just not a lot of people talking about this. But I personally find it more interesting than building models. I'm just not that interested in building models, to be honest.
No, I agree, and I think it's a matter of commoditizing, right? And I think this is one step towards the commoditization, I believe. So we all want to get away from the point of building models, and so something like this that creates that level of automation and simplifies the process. It's, in my opinion, a good step in that direction. So. And yeah, and so again, this was one example for text. There's the same thing applies to sequence and series audio, and also we have different implementations, different models for images with both pre-trained and non-pre-trained models. And the same is true for other features. I don't want to bore you with going through all of them, honestly. I just wanted to touch 1 second on the combiner aspect. Basically, we need this combiner because it's basically, if you have multiple features and basically you have all these vectors coming from all these encoders, you need a mechanism for merging them somehow, combining them somehow. And so here we implement some, the most simple one is this concat thing that concatenates the vectors and then uses fully connected layers. But we have also other like state-of-the-art models, in particular for tabular data like tabnet and tab transformers and others. So it's, again, it's the same concept for the input features, just configuration. You can change the details, which models you want to use and which parameters, if you want to change the parameters. And again, the same applies also for the outputs. And different outputs you can specify for each of them, the loss and other specific parameters. For instance, number for doing regression, binary for doing binary classification, category for doing multi-class classification, and you have like many different additional pieces to the loss, so you can add and tune and change if you need so, and set for doing multi-label classification, vector for doing, usually it's used for like predicting soft labels, like probability distribution across different labels. And sequence can be used both for tagging and for generating tokens one by one in an autoregressive way. So for instance, generating text or generating sequence of decisions. This I'm going to skip. And then the last two sections are the training part of the configuration, where, again, you don't have to specify any of this, but if you want, you can change the batch size, the early stopping, the optimizer that you want to use, the learning rate, how the learning rate decay, and all of this. You don't have to, just a configuration away.
Are you using some, like, for your defaults, are you using some kind of like Bayesian, optimization to pick hyperparameters, or is
so for the defaults, they're just defaults, just values that we figured out empirically through experience and also like getting them from literature, depending on the specifics. But there's an hyperparameter section that I'm going to talk in a second, where you actually can define how you want to find those hyperparameters. And then pre-processing wise, you can specify, for instance, depending on the data type, you want to, pre-process the data, you want to tokenize text, for instance, or you want to encode categories, or you want to normalize numerical features. So basically all the common transformations that happen before and after the model, they're also part of the parameters you can specify. Great. And so usually here I show some example models. This is like the first one, the text classification one. The configuration you see on the right is all you need to specify. But you can do image classification with just changing the configuration to image path and the type to image and the encoder, in this case, for instance, to stack CNN. Or if you want to do speaker verification, where you have two files and you want to see if there's the same person speaking or not, then you can specify two inputs, say that the weights are tied with the tied parameter, and then just have a binary output classification. This is an example similar to what I was doing at Uber for expected time of delivery, where you have like a restaurant, an order, and what time that order was made, and you want to predict how much time will it take to deliver that order. And you can treat restaurant as a category input, order as a bag input, hour and minute as numerical inputs, and predicting numerical value, which is the expected time of delivery. And you can change the loss. In this case, we use mean absolute error. You can do sequence-to-sequence chit-chat dialog models, or you can do sequence tagging for information extraction, or in this case, name entity recognition. Or you could use it also for doing natural language understanding or summarization if you have like outputs that's this is like extractive summarization, where you could just say, I want to keep or not this word in my input sequence. And you just treat it as an output sequence with a tagger, and this is all you need to do summarization. So this was like a really short and fast set of things that you can do with Ludwig. And then we can go. There's distributed training that this was the initial, what I was mentioning before. The initial version only had limited was limited to what could fit in memory. But what we added right now is that using Ray and Dask, we made it so that basically can be data can be distributed using Dask and run remotely using Ray. And you have to create your Ray configuration for the cluster. But then in Ludwig, you just have to specify Ray submit cluster.yaml and the configuration in Ludwig, basically, and the data in a like a S3 bucket or something that each machine in the cluster has access to.
And are you thinking of some kind of infrastructure as code component to this as well at some point, or is that more the commercial offering?
So I would say the infrastructure code, here you have the specification of the cluster itself, which is the Ray specification, not really ours. But in our own, so this is about hyperparameters. In our own Ludwig configuration, you can also be more granular and say, I want to use 2 GPUs, 3 GPUs, and distribute across these machines and all of that. So you have a little bit, you have the control over that directly, I would say.
So you could, I'm just thinking out, I just happened to be finishing a book on AWS for O'Reilly. So I'm thinking it's infrastructure as code a lot. And like they have CDK, for example, and there's Terraform there. But the idea would be that if you checked in this configuration alongside, let's say, CDK, right, which runs in Python, you could kind of, basically have continuous delivery of the infrastructure as well as the
model training pipeline. Yeah, definitely, 100%. Yeah. That's super fascinating and definitely doable because it's just an additional YAML file you have to provide, basically.
Exactly.
And the command, really.
Yeah.
And then we also do hyperopt, as I was mentioning before, parallelized using RayTune. And basically you can declaratively in the configuration specify which parameters you want to optimize, their ranges, and which metric you want to optimize, and also which search algorithm. And you can go all the way down to like Bayesian optimization with hyperband, with big number of samples. Basically, you have the full flexibility just for the configuration, no line of code. You don't have to write any line of code.
And the RayTune, is that something that is that your own system, or is that an open source?
No, it's based on top of Ray. Yeah, so it's open source, and we're basically wrapping it and doing all the gluing and all the spawning and collecting of the results and all of that. And so the RayTune gives the infrastructure for running that in parallel over multiple machines.
And do you have like a range of multi GPU clusters that you've trained things on? Like, have you personally or know of people that have trained on, like, I don't know, 10 GPUs or?
Yeah. So we have our own infrastructure for running our own things, and also on hundreds, if not in case thousands of GPUs potentially. Really? So it scales really well to those. In particular, Horabot, which is one of the components that we use for distributing, has been used in the IBM Summit supercomputer with literally thousands of GPUs and almost linear scaling. So
wow,
scales really well. And for instance, we have also integrations with some technologies in the MLOps ecosystem. Like for instance, if you want to track the model on weights and biases on Comet or MLflow, you just have to specify the additional thing in the command, and that's all you have to do for the model training and deployment to be tracked by those technologies. And also you can run very easily on Kubernetes, like just running, installing Kubernetes, running the array cluster, and then just create a Ludwig training.yaml and run on the Kubernetes cluster. So it's really straightforward. Cool. And then I just wanted to quickly touch upon Predibase specifically. So we do this aspect that I was mentioning of managing Ludwig training and tracking and all of that, and infrastructure and provisioning machines, etc., all in Predibase. And basically you have like a turnkey solution with managed plus virtual private cloud deployments of Kubernetes cluster, scales on thousands of GPUs and petabytes of data. You deploy models with one click and they become available through a REST API. And you can there's both Python SDK, REST endpoints, and a SQL-like language for operationalizing it. And I wanted to touch upon briefly the SQL-like language here on the right-hand side because I think it's cool. You can both create models, but in particular, you can query models by just specifying an additional predicate on top of SQL that is like predict. In this case, you can say like predict conversion given and select the customers from my customers table where something is true. And so basically we could do data, let's say we're trying to bring machine learning and data in the same place so that you don't have to, select some data, save it to a CSV file, upload it somewhere, produce the predictions, analyzing them manually first, give them back to the analysts and whatever. So it's all happening in one place and becomes very easy for someone who doesn't have machine learning expertise to actually use machine learning models within